This is a Carboline production.
Leak-sealing grouts are essential weapons in the hidden fight against leaks in underground piping or other infrastructure. And within water and wastewater collection networks, acrylamide grout technology is far and away the material of choice. So what is it? How does it work? And how does it fit into the bigger picture of water collection network maintenance and repair? We answer those questions on this episode of The Red Bucket. Today, The Red Bucket is very, very happy to have Michael Vargo of Prime Resins joining us. Michael, welcome, and please give us an introduction to yourself and to your role at Prime Resins.
Yeah, thank you, and I'm glad to be here. My name is Michael Vargo with Prime Resins. I started here in 1991, helping in the tech support or problem-solving department, sales and tech support. So that's predominantly where I'm at today, is helping solve problems for our customers, our owners, in municipalities.
Some listeners may know this, some others may not, that there is a relationship between Carboline and Prime Resins. Michael, maybe you can share more about how that has evolved over the last half a decade or so.
Yeah, in 2017, Prime Resins was purchased by RPM, and through some structural changes in the last year and a half or so, in June of 2023, we came to report under the Carboline umbrella as opposed to the USL umbrella.
It's possible this episode will publish right around that time period of June, so I will hedge my bet and say, if that's the case, happy anniversary. We're glad to have you these last couple of years.
It's a good fit for us.
Yeah, we think so too. So the subject of our talk today is acrylamide grouts. And as I seem to do in almost every episode that we have, I admit my ignorance, which is to say I don't know very much about this. So how would you paint the picture? Give us that introduction to this technology and this technology in the context of the other common ones that you might see in leak sealing and in soil stabilization.
Sure. The acrylamide is what we call a true solution grout, meaning it's a liquid grout, unlike cement. And there's microfine cements and there's polyurethanes and there's other things that we compete with in this arena. But in the case of a cement grout or microfine cement, you've got cement particles, you've got sand that can influence how that material migrates, especially in a geotech application, how it permeates through the soils. The acrylamide has some advantages there because we don't have those particles to deal with. The other product selection typically we run into in this arena is polyurethane grouts. Polyurethane grouts have their place, and we also do those, but polyurethanes tend to have a higher viscosity. So again, certain applications require certain properties, and in each of those, the cement grouts, the urethane grouts, the acrylamides and acrylates, all have their niches when it comes to application in the field.
And while we don't really intend that this is a sales pitch podcast, there is a product, an acrylamide grout product, which Prime offers. And if you could talk about that product, Michael, I think that might be a good way to sort of add some color to the picture we're trying to paint here.
Sure. So with the acrylamide, it's called our PR10, and we have two versions. We have a PR10L, which stands for liquid, and then we have just the standard PR10, which is actually a granular material that comes in a bag. The PR10L, we also have NSF 61 potable water certification on for applications where that may be required.
And where do we see this material most often used in the municipal water and wastewater collection leak sealing context?
If we're using this in a sewer application, and again, the main line and lateral. So the main line is basically the part of the sewer collection system that runs along the street from your house or your business to the treatment plant. That's basically encompasses the collection systems. That's pipes. The laterals are basically the pipes that come out of the business or out of the house that tie into the sewer at the street. So that lateral connection is between the building and the main pipe at the street level. And then the main line is what travels along the streets or through the right-of-ways to convey it ultimately to the treatment plant. And obviously everywhere in there you've got manholes also that provide access points, checkpoints if there's blockages, things like that. There's a variety of reasons for a manhole. In that you've got small diameter pipes. You've got to use specialty type equipment to be able to go in and seal the leaks in that lateral and in the main line. A lot of times you're dealing with 4, 6, 8, 10, 12-inch pipes. So obviously it's, you can't get inside there to do it manually, so you've got to be able to grout from internally. Logiball happens to be a sister company to Prime Resins, and they actually manufacture these highly sophisticated specialty packers to do this type of grouting, where we can grout the connection and we can also grout the joints in the collection system. And obviously you've got clay pipes, you've got a joint every 30 to 36 inches. If it's concrete pipe, then your spacing is 5 or 6 feet depending on the diameter. And all those joints tend to be a leak area. In the back of this truck, you've got an operator who's got a camera, and there's a camera that's being pulled through the pipeline so they can visually see the joints, see if they're leaking or not, if the lateral connection is leaking, etc. So they've got this camera that the operator can visually see and control with a joystick, and he can pull that down the pipe. Looking backwards is this packer that's made by Logiball or whoever that actually does the work. So the operator can, by flipping a series of switches, he can introduce the A chemical, the B chemical. He can inject water, air. He can vacuum test or water air test the joint to see if it's leaking. So in the back of this truck, you've got mixing equipment. You've got a tank A and a tank B. So whether you're using the liquid format or the granular format, you still have two tanks. And in the A tank, you're adding water. And if you're using the granulars, you're dumping the bag, a 50-pound bag of the granules into that to be dissolved. If you're using the PR10L, you're taking 3 5-gallon pails of the acrylamide liquid and dumping them into the tank. So in the A tank, you've got water. You've either got the granules or the liquid. And then you're going to add another product called triethylamine, or what's commonly referred to as TEA. And the TEA helps alter the reaction time that we're looking for once the two materials come together. In tank B, also 60 gallons, you're going to have water, and to that you're going to add a salt, typically ammonium persulfate or sodium persulfate, in small percentages. And typically the amount of T in the A tank and the percentage of salt in the B tank are going to be relatively close to the same. So if you're adding 1.5% T, you're going to add roughly 1.5% of the salt in the B tank. And then you're going to fill those up to 30 gallons. So from one 50-pound bag, you're generating 60 gallons of what we call pumpable grout. With the liquid, you're taking a 15-gallon, 3 5-gallon pails, dumping it into the tank, and also, same method, you're making a 60-gallon batch. And then that material goes out through a long hose reel to the packer that's in the pipe and is injected at a 1-to-1 ratio. So equal volumes of A to equal volumes of B. Depending on the amount of T and AP or SP we add, we can manipulate that reaction time. We can have that grout react as quick as 5 seconds, or using some retarders in the tank, we can also delay that reaction for hours if we need to. But typically in the sewer industry, you're working with about a 40 to 50 second set time. So when the operator injects the grout and pushes it out into the joint in that mainline sewer, they're going to wait about a minute. He's going to air test or water test that joint to make sure it's sealed. If it doesn't, he does another shot of grout. If it's sealed, then he deflates that packer, moves it down to the next joint that needs addressed.
That's kind of a stunning range of set times there, from a few seconds to hours.
It is, and in the sewer industry, again, we work typically with a much tighter range. When we get into the geotech applications, we're injecting it into the soil, or we're curtain grouting, say, a below-grade tank that we got access that we can get into, or we can drive probes on the outside to inject it, then that's where we typically see the longer reaction times needed to give that grout more time to migrate or penetrate through the soil or migrate out from the point of injection. Then we can use a retarder, typically potassium ferrocyanide, gets added to the A tank to retard or slow down that set time. So again, being able to manipulate the properties of this grout to suit the conditions we're in is one of the nice things about this material, and kind of separates it from some of the other competing technologies.
If you were to describe, like, features or benefits, either in terms of performance or application, between the solid form and the liquid form? How would you draw that comparison?
The bagged or granular grout has been around for a couple of decades. That's the original way that the acrylamide grout was offered in the marketplace, was in a granular format. However, during the handling and mixing of that material, basically we're dissolving that in water. So if you visualize in the back of a specialty truck, we call a TV grout truck, that's used for mainline and lateral grouting, you've got 60-gallon tanks. And so a worker has to take that bag, he's filling the tanks partway full of water, they're dumping these granular material into the tank, and that creates airborne dust. And that's a health and safety issue. And that dust gets on everything in the truck, then the worker's touching things, he's doing tools, he's touching the tank, and then he takes a break and maybe he doesn't wash his hands as he's supposed to. So it became an issue with OSHA, and there's actually training that has to be done to use the acrylamide type materials. It's both for the liquid and the granular, but it started off in the granular because that was the original format of how the grout was supplied. So there is some health and safety issues. The advantage of the liquid is we eliminate that potential for dust to get introduced into the back of the truck, on the worker, in the air that he's breathing, things like that. So from a EH&S standpoint, the liquid is a much better option when it comes to that. The other interesting feature on this is the material is endothermic. So when we dump the granular material into the water and it starts to dissolve, it actually cools down. It pulls heat out. It actually cools the liquid material as it dissolves. Back in the early days, the TV trucks used to have heaters in the tanks, and they could just turn the heaters up to reheat that material back to, basically ambient, or ideally, 65 to 75 degree temperatures, so they can get predictable reaction times. When the manufacturers quit putting the tanks heaters in, that created a problem, because now if you're doing the bags, you've got to dump the bags in the water, and then you've got to wait for that material to warm back up before you use it. Otherwise, your set times are going to be affected. By introducing the liquid, you're just pouring the liquid into the tanks and you're ready to go. You don't have that reaction. That reaction's already occurred here at the factory when it's made. So you don't have that dwell time that you're having to wait on versus the granular.
On the subject of, I guess, environmental conditions, or let's say ambient external conditions, you mentioned this TV truck. Is it the case that the weather outside really doesn't matter so much when you are going to be applying or injecting this product, whether it's the liquid version or the granule version?
I think to a degree there's always going to be an influence of weather, whether we're doing the sewer work or even the geotech work. Probably the weather more impactful on the geotech work, but even in the sewer industry, in the back of this truck, you've got typically a hose reel that's got 400 or 500 lineal feet of hose that's wrapped up on this huge reel that sits on the back end of this truck, and that's what actually goes down the manhole and is fed up the line. So we're grouting typically between two different manholes, and those manholes may be 300, 350 feet apart. So you've got that hose, so you get material in the tank that's somewhat sheltered, okay, so that's a little bit less of an issue there. But then you've got all this material in the hose, and that hose could be sitting in the back of that truck where it's exposed to the sun. It could be a cold day and you've got a cold breeze or wind blowing on that hose reel, plus whatever's down in the sewer. So from a temperature standpoint, there is some sensitivity to that, and we want to be able to manipulate that reaction time based on the conditions, and that's why the ability to add the T and AP or SP salt gives us the ability to do what we call a cup test. So they'll squirt some material in the cup, they'll test it to see if the gel time or the reaction time is what they want, and like I said, in certain conditions they may speed it up or slow it down to suit the environmental aspect.
What is the decision making for when acrylamide, whether that's granule or it's liquid or something else, is the best for whatever your given problem is?
I think in the sewer market where we're dealing with main lines and laterals, that market is probably 95% dominated by acrylamide. We do have a couple of municipalities who will specify a polyurethane gel, kind of like our hydrogel SX, in lieu of acrylamide The acrylamide, when it cures, it's a flexible, rubbery, kind of a jello type material to give you an idea once it reacts and cures. So it's elastic, so it allows for a little bit of movement in the joints. If the sewer is running underneath the road, obviously you get a pumping action from the vehicle traffic overhead, especially in some of your shallower manholes. So you want to have some flexibility in that material, but it's not super strong. And the urethanes are a stronger, higher tensile, more, if you were to pull it, try to tear it apart, the urethanes have a higher tensile or higher resistance to tearing versus the acrylamide. But in the sewer market, it's pretty dominant. When we start getting into the geotech world, we're injecting it into the soils on a dam or a canal or around a tank, a below-grade tank or elevator pit or tunnel, then obviously we compete more with sodium silicates. We're competing with microfine cements. There are, and even more urethane type products. So there are different products there, and it really depends on the conditions of the soil. We get into a real fine silty sand or silty soil, you can't use a urethane typically because they're too thick, they're too viscous. You can't use microfines because, again, you get separation of the particles in the water and caking occurs, and then the grout doesn't migrate. Where the acrylamide, because it is that true solution grout, even in a real fine silty soil, and I don't want to get too far into the weeds on the geotechnical side, but we can grout soils up to about 30% fines passing a number 200 sieve, and you cannot do that with the microfines, and you certainly can't do it with a urethane grout typically.
We've done a lot of talking about water and wastewater collections, but what are some common applications or use cases for these materials outside of that?
Yeah, I think if we look at the mining industry in the last 5-10 years has migrated somewhat to the acrylamide and the acrylate type grouting because of the ease of getting it to the location where they want to pump it. I mean, we can supply this. Not only we talked earlier about the bags and the 15-gallon units of liquids, but for some of the geotechnical work and the mining and the tunneling type applications, we supply this product in 275-gallon tote containers. So when you're dealing with large volumes that you would typically deal with in the tunneling and mining and stuff like that, they're going through a lot of material. You're not going to want to sit there and mix up bag after bag after bag of small batches. You want to be able to hook up and pump. So the totes offer that ability to for large applications. For example, a project we're doing is subway tunnels. In the subway market, typically about every 400 feet, they have to build what they call a cross passage. And basically, a cross passage is a connecting point between the two tunnels. The tunnels themselves are done with a large boring machine that create these long tubes underground. But from a utility standpoint, if there's ever an accident and they've got to get people vacated out, God forbid there's an accident and a fire in the subway tunnels, you've got to be able to get people from one tube to another to get them safely out and evacuated from the tube. So when they go to cut the actual tunnel liner, you've got to worry about loose soils, high groundwater that could flood the pit that makes it not safe for the workers doing the actual construction, but also long-term support. So with that, like I said, you're a lot of times you're pumping hundreds, if not thousands of gallons, and you just can't do that mixing a bag at a time. So by being able to do the totes and the liquid, it gives that market a much easier way to pump those higher volumes. Same thing with some of the below-grade tanks. You need something that can create a barrier on the backside of the concrete to block the water. Then we've seen applications where the acrylamide worked very well to create that blanket because, again, it's very thin. We drill a grid pattern through the wall. We inject this in. It migrates and basically creates a blanket on the backside. So the acrylamides kind of compete with the urethanes in that market, but it can go either way, just depending on what the owner is looking for or what the contractor's preference may be.
You mentioned the granules were the original conception of this technology, and then later on we have the liquid version. If you were advising an owner on which is the right one to do, how do you have that discussion with them? What are you telling them so that they are making what you think is the right decision on granule versus liquid?
On the liquid PR10L, we do have NSF 61 potable water certification, and to our knowledge, we were the first company to offer a NSF 61 potable water compliant or certified acrylamide grout. And where this kind of stemmed from is we see owners and engineers looking more at the full cycle of water and wastewater. Basically you get water, you're then now using it and you're creating sewage, but then that treated sewage, once it goes through the treatment process, gets reintroduced back into a creek, a stream, a river, some body of water. And that body of water ultimately downstream or downline is also another town or another jurisdiction's drinking water source. So as the industry and the engineering and the municipalities themselves started looking at that full circle life of water, they got to thinking, yeah, we don't need NSF because it's not potable water. We're dealing with sewage, but then that mindset came of, well, today it's sewage, but as we improve the treatment process and we're putting it back into the environment, we've got to be concerned about everything we do in that entire cycle. So we started seeing the sewer guys asking, hey, is there anything in this material that can leach out into the water that's going through the pipes, or more importantly, into the environment? If we're injecting this in mainline and sewer grouting, or if we're using it for soil stabilization, we're injecting it into the ground, and that's coming in contact with groundwater. Is there a concern of anything that could leach out of this grout that could be harmful for that surrounding groundwater? And that's why we kind of took it upon ourselves to say, okay, we will get this tested and work with the labs to come up with a test method to be able to measure, is there anything coming off of this that would have any concerns or raise any eyebrows? And when we did that, and we went to the municipalities and the engineering community and said, hey, we've got this, they thought it was a wonderful thing. It gave them a comfort level that, hey, we can use this without any worry that we're doing harm anywhere in the ground or in the water. The granular is a little bit tougher to do because the granulars you're mixing on site. The PR10L we're making in a factory, it's consistent from batch to batch, and we can test that. But when we take granules and you dissolve it into a tank, it's a little bit harder because that recipe can be altered a little bit by the guy in the field. So it's harder to do a granular. So one of the advantages to the liquid is having that assurance that it's been tested and certified that there's nothing that's going to leach out of that into the groundwater.
I assume that the nature or the quality of the water that they are using to mix that with the bagged version in the A tank, you don't want to just pull that water from anywhere.
Typically they're pulling potable water or pulling water either from a hydrant or a potable water source. Typically you're not going to use creek water or lake water or pond water, something like that to mix it. You're typically using either it could be a well supplied or it could be a municipal supplied. But in reality, they're typically pulling from a quote-unquote potable source of water.
Well, Michael, as I visualize the job of a technician preparing this material for use, the mixing, the measuring, and recalling what you said that there are some health and safety factors involved in its use too, I'm guessing that acrylamides are not just plug and play, so to speak.
In order to use the acrylamides, there is some specialty training that has to be done. Typically, in the past, each manufacturer did the training, and then probably about a year and a half ago, there's a trade association called NASCO, National Association of Sanitary Sewer Contractors. And as a national organization, they decided that maybe they should be the ones that offer this training, and it's a handling and safety training. Again, you're dealing with multiple different chemicals. If you're doing the bags, you've got the inhalation hazards and things like that. So OSHA mandated years ago that there be training involved. Not just anybody can go buy a bag of this stuff and use it. There is a required training course, and that can be done through NASCO online, or you can be done by us as a manufacturer. We can offer the class as well, but there is some safety aspects of this, and they need to be properly trained in the handling and storage and mixing of these materials.
I will just throw the plug out there for Prime Resins generally as a source of training and education. In the case of this type of technology, the acrylamides, it's mandatory, so you have to be trained on it. But right. I see from just sort of being adjacent to what you all are doing that you are providing a lot of training on a lot of topics to folks. So anybody who's thinking about this, maybe it's news to them that acrylamides, that to use these, you're going to need to be trained. One of the reasons you might consider Prime over somebody else is these guys are really good at providing this education.
We pride ourselves on our technical support and our technical ability and helping walk the contractor through this. If it's somebody who's experienced it, we're still here to help you. If you're somebody kind of new to this, then we're here to provide as much knowledge and resources on not only the chemical but the equipment and the how-to. And if you need packers, we can reach out to Logiball and get that. So we try to be, as much as we can, a one-stop source and a resource for not only our contractor customers but also the municipalities and to the engineering community as well.
Just from conversations that I've had with folks in the industry or colleagues here within Carboline or with Prime, it seems to me like it's never just one thing. There's a couple things going on with, at any given location or with any given municipality. So before I go on, is that the case? Does that track with your experience?
Yeah, it is. And one of the biggest issue these municipalities face is when they've got leaky joints in the sewer collection system, it's bringing water in that they now have to convey and treat. So if you get a nice sunny day, that pipe may be carrying, let's just hypothetically say that section of pipe from point A to point B is maybe transmitting 50,000 gallons of sewage a day. Then all of a sudden you get a rain event, it rains for a couple of hours. Well, it may spike that flow to 200,000 gallons or maybe even more, depending on the amount of leaks and how long a section that we're talking about. So it tends to surcharge the plant, and then the plant gets to where it's got more sewage and water flowing through that pipe to the plant than the plant can handle. And then they wind up having to do a bypass or a discharge or figure out somehow to store it until the plant can catch up. But in addition to having the added cost of treating that water, it's also generally carrying fines, soil particles out of the soil. And that adds two compounding problems to the scenario. One is that sand and grit that's being carried in with that water scours the pipes. If they're using pump stations or lift stations at intermediate points, now you've got this building up, the sediment and silt building up in those elevations that need to be cleaned out. And two, it removes soil from around the pipe. So now the pipe has the ability, because there's now a void where that lost soil is, there's a potential for that connection to shift, the pipe to become misaligned. It can drop or it can shift to the left or right. Typically it drops. So you lose support of the pipe. And with the grouting, with the acrylamide, PR10, it doesn't matter if it's the liquid or the granular, what we're doing is when we inject that, it's going out through the joint and it's creating a collar around the outside of that connection. So it reinforces the connection. It will fill minor voids into the soil so that now that is properly supported and can't become misaligned. And even if they're doing a we'll call it a relining project, where we actually run a liner through the inside of the pipe to rehabilitate the inside, typically grouting's got to be done to stop the infiltration before you can even run a liner, a segmental liner, or CIPP, cure in place type liner through the inside of that pipe to rehabilitate it. Generally, grouting is the first step to all that.
Try and answer this without being biased, which probably is impossible. But you did mention sister company Logiball a few minutes ago. Of course, this is a Carboline podcast. I'm with Carboline. But there's a benefit to customers there. And the same would be true if we were talking about, three other companies that had nothing to do with the people who sign our paychecks, right? But from your point of view, when you're able to provide them what Prime has to offer, but also connect them with Logiball and also connect them with Carboline, because the leak sealing or soil stabilization part of a project is just part of it. It's in an ecosystem of other things that might be happening. And we have these solutions under one roof. This is good for customers, but how would you describe the way that that's good?
As we seal the leaks in the main lines and the laterals, again, I mentioned earlier that groundwater's still down there trying to find somewhere to go. And if it can't relieve itself through the joints and through the laterals, because we've now sealed them, the tendency is now it directs it to the manholes. And like I said, in a sewer system, you've got manholes every 300 to 400 feet. So you may have a jurisdiction, a medium-sized town might have 50, 60,000 manholes. Larger municipalities, you're talking hundreds of thousands of manholes. So obviously, we see a lot of our applicators that are doing the grouting work, also working with the manhole rehab people, and they're having to rehabilitate those manholes as well. So they use the acrylamide or even some of our urethane grouts to seal the leaks in the manholes, and all that's prior to them being able to put on a Carboline product such as the 6500 hydroplate. Obviously, part of the rehabilitation of these manholes is relining them, and the hydroplate is a great material. We've got several applicators that just love spraying the hydroplate inside these manholes, but you've got to stop the leaks. Then you can rehabilitate the rest of the structure. Same thing as if you've got a below-grade treatment plant tank somewhere that needs coating or lined, and obviously that's definitely Carboline's arena. Is if it's got cracks that are leaking, if it's leaking at the wall to floor joint, we've got to go in there with the Prime products, seal those leaks, whichever way we deem best, whether we go through wall or probe grouting, and get that tank dry so that they can come in with the Carboline. And for us, and for the owner's benefit, is sole source. A lot of engineers, if there's a problem on a project, they don't want a bunch of finger pointing. They don't want the coatings guy pointing to the leak seal guy who's pointing to this, and the engineer and the contractor said, well, I used what was specified. So the fact that together with Prime Resins, Logiball in the sewer arena, or just Prime and Carboline, is we can give the owner and the engineer sole source accountability. If there's a problem in any step along the way, they're dealing with us as kind of a whole, rather than two or three people pointing fingers at each other trying to escape liability or culpability. So I think for an engineer and an owner, that comfort of having a sole source expert who knows the project from start to finish, they know what's being used for the coating, they know what's used for the leak seal, they can make recommendations because we've got more intimate knowledge of that project than probably anybody else, especially if you're dealing with two or three different vendors. For the applicator, for the contractor that's actually doing the work, it's easier for him. He's used to dealing with Carboline, or he's used to dealing with the Prime Resins technical or sales staff. Order entry is easy. Things come in, it all can come in together, be coordinated and scheduled. So even from the applicator, if there's a warranty issued, it's much easier when you've got less people in the mix. It's a win for everybody.
I think there's a level of comfort for us, knowing that it's a team effort. In a lot of cases, a job might come up, and it starts with the connection that the owner or whoever might have with one Carboline guy, right? And Carboline guy doesn't necessarily need to be the, final answer, because they can come back and say, hey, Michael, look, I've got a problem. It's just easier for us to be helpful, I think.
I'll never fully understand the coatings market. That coatings market was never a forte of Prime Resins, but we do know the leak seal. So, yeah, you can lean on a team of experts that know their segment of that job. And, yeah, there's times that we'll call a Carboline guy and say, hey, we're doing some leak seal on this thing, but they've got a tank that they're looking at rehabbing in 2 or 3 months, and we need your expertise, and we'll tag team. And vice versa. We've had the Carboline guys call us and say, hey, we're trying to coat this tank. They've got some leaks. We got to figure out how to seal these leaks so we can get the lining in place. So it is a mutual joint benefit.
And with that, I think it's a good time to draw this conversation to a close, because we'll all jointly benefit from Michael's answers to the 4 questions. And the first one is, would you rather be 1 inch shorter or 1 foot taller?
Ooh, see, they make me nervous with these questions. I don't know. So let's see, the 1 inch shorter or a foot taller. I'm 5'10", a foot taller, 6'10". Nah, I think I'd take an inch shorter than a foot taller. I don't want to be as tall as Jeremy Sokola.
Yeah, and I know he's going to hear this, so.
I'd rather be short like David Dingler than Jeremy.
Shots fired. Question number 2. If you were forced to spend a day in a museum, but they let you choose what kind of museum it was, what would you choose?
Ooh, that's tough. The Smithsonian Institute, for sure, but they've got so many different museums within the Smithsonian Institute. I think something having to do with technology. All my life I've been kind of a problem solver, so I think some of the modern equipment or machinery and technology side of things. In Chicago, you've got the Science and Industry Museum in Chicago, so maybe I'll change it. Maybe it's not the Smithsonian, maybe it's the Chicago Museum of Industry and Science.
I've been there, but I was too young to, I think, fully appreciate it, because it was a junior high school field trip, which it probably was fun at that time too, and I don't remember it too well, but I almost think stuff like that, you need to be an adult to really, really get the most out of it.
To grasp, yeah.
Question number 3, name a city or a state that surprised you for how fun or interesting it was.
I've been to a lot of places. Does it have to be in the U.S.?
No.
I think probably the city that surprised me the most was Moscow when I went to Russia. just the size of the buildings. I mean, a building takes up the entire block in a lot of cases, or multiple blocks, and the streets are super wide. You'd have these streets in the middle of towns that were 4, 5, 6, 7, 8 lanes wide.
Did you get a chance to ride in their subway?
I did.
It's a really good one, isn't it?
Yes, it is a good one, and a lot of it's really deep underground. I mean, you get some long escalators to get in and out, and they're very decorative.
All right, question number 4. Because we've had the nice weather finally get to us here in the Midwest, and maybe it's been around for a little longer for you where you are, but it's grilling season. What is your favorite thing to grill?
I love a good New York strip steak. But a New York strip, I could eat that every day of the week.
How are you cooking it?
I usually like it medium, just a little bit of paint. I don't want it too bloody, but just probably a medium to just a smidge over medium is the best way to cook that.
It wouldn't be the Red Bucket if we didn't end the show feeling hungry after talking about food. So, Michael, I'm so glad you could join us. Thank you for sharing your knowledge.
My pleasure, anytime.